It's a beautiful morning. I think I'll go outside for a while and just smile. Just taking some clean, fresh air. Oh, no sense in staying inside. If the weather's fine and you got the time, it's your chance to wake up and plan another brand new day. Either way, it's beautiful.
Hi class, so as you can see this morning, I had a little trouble making my lights work, so I was hoping that maybe you could shed some light on my situation and help me figure out what went wrong. So before we get started, we should probably figure out how electricity really works. So you're each going to use your workbook, and we're going to figure out how electricity functions. So the constant flow of electrons is called electric current, so go ahead and fill it in on the blank. So to expound on that, you're going to have a bunch of electrons, and they're negatively charged as we learned before. We're going to draw a bunch of electrons, negative, and they're just freely moving. And that's going to be how electricity is going to be created. So, a strong electric current is produced when many electrons pass a point in a short amount of time. So in your blank, you're going to say strong. Now, the other half of that is that a weak electric current is produced when fewer electrons pass the point at the same amount of time. So go ahead and fill in weak. Alright, so to help us understand this, we're actually going to be using a series circuit. So we're going to go ahead and draw a series circuit, and I'm going to have you draw it in your book as well. Alright, so the series circuit is what we're going to be using for the whole entire experiment that we're going to do later and for our notes today. So we're going to draw a series circuit just so we understand what we're working with. So you're going to have your light bulb. And that is what we are trying to get to work, just like Miss Goodrich struggled with this morning. Then you're going to have wires, and they're going to attach to a battery, okay? So here's our battery, and that's going to be where our energy source is coming from. Then we're going to leave this open, so we're going to create an open circuit. And that is where we're going to plug stuff in to test the conductivity of something, which we'll move on to later. Alright, so go ahead and finish drawing this, and get ready to move on to the next page. Okay, so materials can either increase or decrease the flow of electrons that we had talked about before. So they can either increase or decrease. And the way that I like to think about this is if we had a balloon, and you have a balloon full of air, and when you don't do anything with it, the air just blows right out, right? But if we put our fingers on it and squeeze it a little bit, only a little bit of air comes out. That would be like the material that we're talking about, and with our electrons. Certain things make the air come all the way out, or stop it. Alright, so we're going to talk about what helps pass the electrons through. So that would be called a conductor. So a conductor is a material that helps pass the flow of electrons. So go ahead and fill that in. And conductors are going to be typically metal. So go ahead and pause the video and think of some things maybe around your house that would make great conductors, and go ahead and list them in your notes. Alrighty, now that we understand what a conductor is, go ahead and draw in your series circuit that we had drawn originally and put something in there that would be considered a conductor, and then illustrate to me what the light bulb would do. So remember, a conductor is a material that helps pass the electrons through. Okay, go ahead and do that. Okay, now we're going to talk about insulators. So an insulator is a material that stops the passing of electrons. So go ahead and fill that in your notes. Insulators are typically non-metals. Okay, so how we thought about this with the balloon is that that would be like our fingers stopping the air coming out. The same is true with a circuit. So you're going to have some object in there that's going to stop the electrons from passing through to the light bulb. Okay? So pause the video and think of some objects in your house that would be considered an inhibitor, or an insulator, I'm sorry. Now you've done that, go ahead and draw your series circuit again, just like you've done before. And I want you to illustrate what the light bulb would do with an insulator in there. So go ahead and also put an insulator, whatever object you would like in there to represent an insulator. Alright, so just a quick review. I have 2 teaspoons here. One of them is metal and one of them is plastic. So if I were building my series circuit and I wanted to put something into my series circuit that would make the electrons keep moving to make my light bulb turn on, would I use my plastic one or would I use my metal one? Obviously, I would use my metal one because this would be a good conductor while the plastic would stop my electrons. So this would be an insulator. Alright, so finally, how many of you have ever seen cords? Same is true. We plug them into the wall, plug them in our phones, charge them, whatever. But as you can see, something special about the cord that you see in your own house too. They end with metal, and they have metal inside, but for some odd reason, they're wrapped in rubber or plastic or something like that. Why in the world, knowing that this was an insulator, would I wrap it around if I want the electricity to pass through? So go ahead and think about the wires around your house. I want you to think super, super hard and try and figure out why in the world would it be good to put an insulator around the metal, which would be the conductor. Alrighty, I think we have a pretty good understanding of how electricity works. So maybe we can do some experiments now in class tomorrow and figure out why Miss Goodrich's light bulb was not working this morning. Thanks, and I'll see you tomorrow.
It's a beautiful morning.